Okay, guys, does this sheet look familiar to you? Does this look familiar to you? I hope it does, right? It looks very similar to one we've already done, right? Okay, so if we're multiplying things inside the log and I want to separate it out, what do I do with those two things? If I'm multiplying two things in the argument and I want to separate it out into two logs, what do? Log base b of x, plus log base b of y. Because the log of a product is equal to the sum of the logs of the argument. Does it seem a little more familiar to you? Okay. So what about the next one? Log base b of x minus log base b of y. Excellent. The log of a quotient is equal to the difference of the logs of the arguments. What about the last one? P log base b of x. The log of a number raised to a power is the same as the power. One more word here. It's a verb. Times the log of the argument. I figured it was.
You just took that straight out of my brain.
I clearly took that straight out of your brain. Okay? Are we okay on these rules? Do you remember these? Okay, what about these two? What does this equal? Maybe you remember this one better. What's log base b of b equal? 1. When the base and the argument are the same, if the log base and the argument are the same, it is always equal to the understood power of 1. Okay, so this would be 1, because the base and the argument are the same. Okay? Plus, if we put it in exponential form, it would be 2 to the x power equals 2, so x has to be 1, right? Okay, so what about this one right here? It would be p. Very good. Because I would bring this around in front as a multiplier, and then log base b of b is 1, and then p times 1 is p. If I rewrote this in exponential form, it would be 2 to the x power equals 2 to the 6th, so x would have to equal 6. Okay? If the log base and the argument are the same, it's always equal to the power. I don't really like that vocabulary, but we'll go with it for now. Okay? So what about the last one? Remember, this is the one that I kind of said you don't really necessarily always need to know it because our calculators, these things, can do it by themselves. Okay? But what about the change of base property? Do you remember this? This is log of n divided by log of b. Now, because I am a genius, I did realize an application of this that I need to make sure that you know. Okay? Let's say I give you 75 change of base formulas that you have to do tonight. Or I say before the end of class, we're pretending. Okay? And you only get 60 of them done before you leave class. So you're going to go home and get a 0? No. Because most of us have these that have a calculator on them. Well, I don't see any log there. Dun, dun, dun. Look right here. Log. But look what base it is. Base 10. And while I cannot put log base 4 of 32 in there, if I know that it's really log of 32 divided by the log of 4, 32 log divided by 4 log, enter. 2.5. Now, that doesn't really mean anything to you, so let me show you this. Log base 4 of 32. Bam! 2.5. Okay? So if you know the change of base formula, yeah, you may not have a TI Inspire at home, but you do have a phone with the log capability. Those of you who don't have an iPhone, I'm sorry, I don't know about your calculator or not. But iPhones, you can look. Yeah, if you don't have an iPhone, absolutely look. So then that oh, and you can do logs and decimals. Very good point. Okay? So even if you don't have it on your exact calculator, you do have access to the internet where you can get to decimals, correct? Okay. So how would we rewrite this problem and change it with the change of base property? Log of the argument, which is x plus 1, divided by log of 2. Aaron, what kind of phone is that? An Android. Aaron has an Android with a calculator on it, and it has log on there as well. Okay? Is it just the calculator that comes loaded on the phone, or?
Yes.
Okay, calculator came on the phone. It's there as well. Okay? So that's another reason why we need to know change of base formula, because we can actually have no excuses to not do these at home because we have one on our phone. Fair enough? Okay. Let's look at the other paper that you got. Okay? We're going to start with some applications of exponential equations. Okay? Read about each situation. Decide whether each question requires you to evaluate or solve the given function. In every case, show the steps that lead to your answer. All right? I'm going to do some of these for you, and you're going to do the rest. Fair enough? Of course it is. Okay, so let's look at number 1. A piece of paper is about 0.004 inches thick. Geez, this sounds fairly familiar. Oh my goodness, we did a worksheet called Stacking Paper at the very beginning of this unit, didn't we? Okay. If you fold the paper in half, the stack is that thick. If you fold it in half again, it's that thick. And so forth. The equation to model the thickness, which we're going to call T, and it's going to be in inches, of the stack of paper after x folds is here. That means, remembering from our exponential function days, that is a starting number, and that is the common ratio. Do you remember that? Okay. So determine the thickness of the paper after 8 folds. How do we do that? Plug 8 in for x. So we say 0.004 times 2 raised to the 8th power. So 1.024. Well, what does that mean? 1.024 inches thick? Like that thick? Mm-hmm. Yeah. Kind of crazy, huh? Set up and solve an equation to determine about how many folds it required to make a stack 11 feet tall. Now, first of all, they give you a hint. 11 feet is how many inches? Because of the fact that we're using T, the thickness in inches, we have to make sure that that is in inches. Okay? So how many inches is 11 feet? 132 should equal what? 0.004 times 2 to the x power, right? Correct? So how do we solve this for x? Divide by 0.004. 132 divided by 0.004, or 4 thousandths, right? 33,000? 33,000 equals 2 to the x power. How can I get the x out of the exponent? Logarithms, okay? Write it in logarithmic form. Log base 2 of, oops, I missed a 0, sorry about that. 33,000 equals x. We could do change of base formula. We could enter it straight into our calculator. Just depends on the technology that you have, right? So look at the answer and then answer the question. Set up and solve an equation to determine about how many folds it would require to make a stack 11 feet tall. For x, we got 15.0102. But what's my answer? 15 folds. Because first of all, it says about how many folds. And can you have 15.1 folds or 15.01 folds? No. Any questions? We good? Turn it over, please. Let's do one on the back. Which one would you like to do? 8? Is that what you said? 8. A financial genius, so they're clearly talking about me, puts her money into the stock market where she likes to think her investment is earning interest continuously. So here's the formula. Okay? The original investment of $12,000 was valued at $18,000 after 2 years. Find the continuous rate of increase. So we're trying to find R right there. What goes where? What do you think? 12,000 should go in for P. Why should 12,000 go in for P? That's the original investment. Remember with our exponential form that A value is our starting value. And in this case it's a P because that's what they told us. But that's our original investment. Okay? So 12,000 goes here. 2.71828 to what power? R is what I'm trying to solve for, right? Find R. Why would it be 2R? Oh, excellent. 2R. What does it equal? Why? That's its value, right? Very good. Okay, so let's solve for R. How are we going to do that? Divide both sides by 12,000. Obviously, I'm going to run out of room pretty quick. Okay? I don't think I write too big, but whatever. All right? So if you need to do some of your work on another piece, like a piece of notebook paper or whatever, just keep it with this worksheet. Okay? So 18,000 divided by 12,000. Okay, I'm going to just ignore B for a second. I'm going to write right here, okay? Sorry. 1.5 equals 2.71828 to the 2R power. How do I get that out of there? Logarithmic form, right? Log base 2.71828 of 1.5 equals, ooh, it's a little different this time, isn't it? That equals 2R. So we're going to have to divide by 2 to get the answer, right? So we're going to do log base 2.71828 of 1.5 and get an answer. And I need to divide that number by 2 before I can actually solve for R. Okay? So if I divide that number by 2, oh, sorry. R is going to equal what? 0.2027? 0.202733. Okay? So, now here's B. All that's kind of like A, right? At this rate, determine the value of the investment after a total of 8 years. So now we have the rate, don't we? Okay? So now what? What goes where now? I still know what I started with, right? I still started with 12,000. I still have this of 2.71828. What's my exponent? Very good. 8 times that number, right? The R. 0.202733. Okay? So I'm not going to worry about multiplying that by 8 because I'm just going to let the calculator do it for me, right? 12,000 times 2.71828 raised to the 8 times, watch this, this is even easier. Let's see, where is it? Control negative sign. I'm just using that number, aren't I? I'm just using the previous answer. And it's control negative sign. We'll let you do that. And then enter. What's going to be my value? $60,750. Any questions? 3 on this side, 3 on this side. Okay, 6 questions. Sorry about that, yes. Any questions though? Kingston out.